Okay. Good day, students. My name is Mrs. Nneto, N.A., your chemistry teacher. Our topic today is sodium and its compound. Objective: by the end of the lesson, students should be able to 1. Describe the extraction of sodium. 2. Give the properties of sodium. 3. Explain the flame test for sodium. 4. Give the uses of sodium. Sodium is very reactive and do not occur naturally as a pure metal. It occurs as common salt. Example: sodium chloride. It occurs as deposits, that is rock salt. Either you call it sodium chloride or you call it rock salt. Then we have also another example is sodium trioxocarbonate 4 and sodium trioxonitrate 5. Then we move over to how do we extract sodium? Extraction of sodium from its salt. Sodium is extracted by the electrolysis of molten sodium chloride using downcell. The process we use is called down process. It is an electrolytic process. The downcell is a large vessel with volume of about 5 cm3. It is lined inside with fire bricks. The anode is a graphite rod, while the cathode is a steel cylinder surrounding the anode. Fused sodium chloride is placed in cell and heated for about 801 degrees centigrade. That's the melting point. Electrically, and this would lead to a loss of sodium while heating it. Because of the high melting point, calcium chloride is added to lower the melting point to about 600 degrees centigrade. That means the calcium chloride is used as a catalyst to lower the melting point of sodium chloride. During electrolysis, the fused sodium chloride breaks down to give metallic sodium and gaseous chlorine. The sodium metal is held in the region of the cathode. We all know that the sodium will be discharged at the cathode using an iron gauze cylinder and can be piped off. The chlorine is then liberated at the anode and collected as liquid and stored in a cylinder. Now let's go to the chemistry aspect of the reaction. At the cathode, what happens at the cathode? At the cathode, we have sodium ion gaining 1 electron from the cathode to form sodium metal. The sodium ion receives an electron each and becomes reduced to metallic sodium. At the anode, the chlorine ion gives up electron and becomes oxidized to atomic chlorine, which then pairs up to form chlorine gas. You see the equation below. Then we move over to the physical properties of sodium. The first physical properties of sodium is that sodium is a soft silver white metal. It has a melting point. Number 2, it has a melting point of 97.5 degrees centigrade and the boiling point of 890 degrees centigrade. Number 3, it is a good conductor of heat and electricity. Then we'll move over to the chemical properties of sodium. Number 1, exposure to moisture air. Exposure to moisture air. When sodium is exposed to moisture air under the following reactions. 1. Sodium reacts with oxygen of the air to form sodium oxide. So the reaction of sodium with oxygen will give us what we called sodium oxide. Number B, when the sodium oxide absorbed water from the air, it forms sodium hydroxide. When it absorbs water from the air, it will form sodium hydroxide. Then number C, when the sodium hydroxide reacts with carbon 4 oxide in the air, it will give us what we call sodium trioxocarbonate 4 and water. Sodium trioxocarbonate 4 and water. You see the equations below. Because of the reaction of sodium metal with air, sodium metal is kept in oil to prevent it from tarnishing. When you don't keep it inside a container that contains paraffin oil, it will tarnish, it will disappear. When it reacts with air, it disappears. Number 2, combination reactions. Sodium reacts on heating. Sodium combines with hydrogen directly and other nonmetals like fluorine, chlorine, sulfur, etc. Except boron and carbon. Boron, carbon, and nitrogen. Others gives what we call corresponding ionic compounds. Corresponding ionic compounds. Example, you see the reaction between sodium and chlorine to give us a salt called sodium chloride. Number 3, chemical reaction. Sodium reacts with cold water. Sodium reacts with cold water. That is the reaction with cold water. Sodium reacts violently with cold water to give out a lot of heat, hydrogen, and sodium hydroxide. We have 3 products: heat, hydrogen, and sodium hydroxide are being formed when sodium reacts with cold water. You see the equation below. Number 4, reaction. Reaction with acid. Reaction with acid. Sodium reacts vigorously with dilute acid to form salt and hydrogen. To form salt and hydrogen. For instance, the reaction of sodium with dilute hydrochloric acid will give us sodium chloride, which is a salt, and hydrogen gas. sodium chloride, which is a salt, and hydrogen gas. Another chemical properties of sodium is the reaction of sodium with mercury. Reaction of sodium with mercury. Sodium dissolves in mercury to yield sodium amalgam, and this can be used as a reducing agent in organic chemistry. It can be used as a reducing agent in organic chemistry. You see the equation, the reaction between sodium and mercury to give us sodium amalgam, which is a solid. Reaction with ammonia, that's the sixth one. The reaction of sodium with ammonia. Reaction with ammonia, sodium reacts with ammonia to form sodamide and hydrogen. So we have two products here, sodamide and hydrogen. And the formula for sodamide is NaNH2. Then we talk about the test for sodium ions. We have only one test, which is called flame test. Only one test for sodium ions, which is called flame test. All sodium compounds produce a brilliant yellow color when heated on a platinum wire. All sodium compounds produce a brilliant yellow color when heated on a platinum wire. That's the only test for sodium. We talk about the uses of sodium. Uses of sodium. Number one use. Sodium is used in production of sodium peroxide and sodium hydroxide. Sodium is used in production of sodium peroxide and sodium hydroxide. Number two, sodium is used as a heat conductor in nuclear reactions. As a heat conductor in nuclear reactions. It is also used as a vapor in sodium lamps, which are widely used for street lighting. You know our street lighting, that's what we use. So we move over to compounds of sodium. Remember, we talk about the sodium trioxocarbonate. 4 is one of the compounds of sodium. We talk about sodium oxide is one of the compounds of sodium. We talk about sodium trioxocarbonate. 5 is one of the compounds of sodium. Then we have also sodium peroxide is also one of the compounds of sodium. Number 1, we are going to look into sodium oxide. That's the first one we are going to look into. Sodium oxide with the formula Na2O. Sodium oxide with the formula Na2O is prepared when sodium is born in a limited supply of air, or is prepared by heating sodium peroxide gently with excess sodium. When you heat sodium peroxide gently with excess sodium, the product it will yield what we call sodium oxide. That is the only way we can use to prepare sodium oxide. By limited burning of sodium in a limited supply of air, or through heating of sodium peroxide gently with excess sodium. Then we move over to properties. Properties of sodium oxide. Properties of sodium oxide. One of the properties of sodium oxide is that it is a white solid. It is a white solid which reacts violently with water to form sodium hydroxide. When it reacts with water, it gives sodium hydroxide, which is an alkali. Sodium hydroxide is an alkali. It's a base. Number 2, sodium hydroxide also reacts with dilute acid to form salt and water. This reaction, we call it neutralization reaction. The reaction between base and acid gives us salt and water. It is called neutralization reaction. So we move over to another compound of sodium called sodium peroxide with the formula Na2O2. Sodium peroxide. How do we prepare this sodium peroxide in the lab? We can prepare sodium peroxide when sodium is burned with excess oxygen. When you burn sodium with excess oxygen in the lab, it will give you sodium peroxide. The equation is below. Reaction of sodium with excess oxygen gives sodium peroxide. Then we move over to the properties of sodium peroxide. Number 1 property is that it is a pale yellow solid which changes to sodium, hydroxide and sodium trioxocarbonate 4 on exposure to the atmosphere. Remember, initially we said that sodium is being stored in oil because if you don't do that, it will do what? Disappear. If you expose it to air, it will disappear. So when it reacts with air, it will give you what we call sodium hydroxide and sodium trioxocarbonate. Sodium hydroxide, because of the water, and sodium trioxocarbonate because of the carbon 4 oxide that is in the atmosphere. Is that okay? So the equations are below. We have the reaction of sodium peroxide with carbon 4 oxide to give us sodium trioxocarbonate 4 and oxygen. Then the reaction between sodium peroxide and water to give us sodium hydroxide and water. Sodium hydroxide and oxygen, sorry. Another property is that it is a strong oxidizing agent and is used in the production of dyes. We all know what is dyes. It is used in production of what? Dyes. Number 3, it must be stored in airtight containers so that it will not react with water. Remember, when we are discussing about sodium, we said that sodium reacts with cold water vigorously. Therefore, you have to store it in a tight container so that it will not react with water. The next property is that it reacts with ice cold water to produce hydrogen peroxide. So we can use sodium peroxide to produce hydrogen peroxide when you react it with ice cold water. So it's one of the ways by which we can produce hydrogen peroxide. Reaction of sodium peroxide with ice cold water will give us hydrogen peroxide. Then the next one is that it can also produce hydrogen peroxide when it reacts with dilute acid. When it reacts with dilute acid. For instance, the reaction of sodium peroxide with dilute tetraoxosulfate 6 acid will produce hydrogen peroxide, and salt, which is sodium tetraoxosulfate 6 salt, which is sodium tetraoxosulfate 6 salt. Now we move over to the uses of sodium peroxide. Uses of sodium peroxide. One uses of sodium peroxide, one is that it used as a purifier in submarines and portable breathing apparatus when it reacts with carbon 4 oxide to form oxygen and sodium trioxocarbonate 4. I said that it is used as a purifier in submarines and portable breathing apparatus when it reacts with carbon 4 oxide to form oxygen and sodium trioxocarbonate 4. So the equation is below. When you look at the equation, you see the product. So that brings us to the end of the lesson. So here is the assignment. The assignment number 1. Why is sodium metal always stored under oil? Why is sodium metal always stored under oil? Assignment number 2. Sodium is extracted in the down cell. Number 2I, name the electrolytes. II, which substance is added to the electrolytes and why? I. Name the electrodes. So here it comes to the end of the lesson. Good day and God bless you. Take good care of yourself. Stay safe till we meet again.